Hey class, this is Professor Fowler, and this is a video to review how to use the E6B flight computer to calculate wind correction angle, true heading, and ground speed, given an altitude, winds, and a true course and true airspeed. This is a problem that I passed out in class, and I'd like to look at a couple of these problems to just review how to use the computer. But the first thing that we need to do is we need to review how to read the winds aloft forecast. And at the top of this handout, you see there's a winds aloft forecast, which is valid on the 10th of the month at 1800 Zulu for use between 1400 Zulu and 2100 Zulu. And it also says temperatures are negative above 24,000. So they just assume that all temperatures are negative above 24,000 foot altitude. You can see at 24,000 the temperature is minus 27, and then at 30,000 it just says 34. It's just assumed that that's minus 34. So these are altitudes at the top of the winds aloft forecast, and over here on the left side are stations. And these are the wind forecasts for each station at each altitude. So let's look at this problem right here. This problem says that we're going to be flying in or near BNA, which is the Nashville International Airport. So we'll use the forecast for BNA. And it says we're going to be flying at an altitude of 4,500. So if we look at the altitudes at the top here, we don't have 4,500, but we have 3,000 and we have 6,000. So 4,500 is halfway between those two altitudes. So we're going to have to interpolate between these two wind forecasts, in order to determine what the winds will be at 4,500. So we're fortunate in that the wind direction is the same at both altitudes. If it weren't the same, for example, if let's say the winds at 3,000 were 040 and the winds at 6,000 were 090, then we'd have to interpolate between the two. Halfway between 040 and 090 is about 060, 070, so we would use that wind direction. But like I said, we're fortunate in that both altitudes have the same wind direction in the forecast. But the wind speed is different. At 3,000 it's 14 knots, and at 6,000 it's predicted to be 24 knots. So that's a 10 knot difference. Halfway between those two would be 19 knots. So we'll use a winds aloft forecast of 040 at 19 knots. So we can write that in here. Okay, next we need to take the E6B flight computer to calculate wind correction angle, true heading, and ground speed. And the nice thing about the E6B flight computer is that there are a set of step-by-step instructions at the top. The first step is to set the wind direction under the true index. And we got the wind direction to be 040 from the winds aloft forecast. So I'm going to rotate the wind computer to 040 so that 040 aligns with the true index at the top of the computer. Then step 2, mark the wind velocity up from the center point. So I've already done that, but I just want to show you. I usually slide the flight computer so that the center is aligned with 100 knots. So it makes it easy for me to mark up from the center. And we estimated the winds to be 19 knots. So I made a wind mark right there, just below 120. That's 19 knots. And I drew an arrow down to the center. The next step, step 3, is set the true course under the true index. So our true course is given to us here, 200. So we rotate the wind computer to 200 that it's aligned with the true index. And then the next step says slide the wind velocity mark to the true airspeed. Our true airspeed is given to us as 85 knots. Our wind velocity mark is right there. There's 80, 85, 90. So I'll slide the wind velocity mark so it lines up with 85 knots. And then step 5, ground speed reads under the center. Again, the center is right there. So the ground speed would be about 102 knots. Okay, that's 102 knots. So we can write that down for our ground speed. Okay, the next step, step 6, wind correction angle reads between the center line and the wind velocity mark. So the wind velocity mark is over here to the left of the center line, about 4 degrees to the left. So when the wind velocity mark is to the left of the center line, we subtract the wind correction angle. If it were over here on the right side, we would add. But since it's on the left side, we will subtract 4 degrees. That will be our wind correction angle, -4. And we can get the true heading now by taking the true course, subtracting the wind correction angle, and making the true heading 196 degrees. So it's that simple.